Video we're going to look at the rest of the problems on here, starting with number 17. In 17, a 1 gram bullet is fired from a gun. It leaves with a velocity of 500 meters per second. We want to know what the recoil velocity of the gun is. Basically what's happening here is here's our gun, a silly little gun. The bullet leaves this way with a force, right? And Newton's law says that Newton's third law says that every reaction is an equal and opposite reaction. So the force of this bullet going out this direction means that there's an equal and opposite force going in this direction, right? So let's calculate the momentum of the bullet. It's going to be 0.001 kilograms times its velocity, which is 500 meters per second. And what that should be is that should be equal to what happens to the gun, right? So that should be equal to 100 grams, which is 0.1 kilograms, times the velocity of the gun. So we're going to call that V. And so here you get 0.5 if you do this. That's kilogram meter per second. And over here you have 0.1 kilogram times your velocity. And if you solve for velocity, you'll get 0.5 divided by 0.1 is 5 meters per second, right? So the bullet leaves at 500 meters per second. The equal and opposite reaction is that the gun is traveling at 5 meters per second backwards, right? That's how hard it would hit your shoulder if you were holding it against your shoulder. Okay, 18, a car of mass 800 kilograms is moving at 10 meters per second and then stops suddenly. Its final speed is 0. Determine the impulse. Remember, so impulse is the same as change in momentum, right? So change in momentum is basically momentum after minus momentum, let's say final, that's a better word, minus momentum initial. So the impulse here is the final momentum is 0 minus the initial momentum is 800 times 10. So the impulse is and we're going to make it positive because we don't care about sign for impulse. 8,000 kilogram meters per second because it's just change. How much did it change by? And you could say negative if you wanted to, meaning it went down by 8,000, or you could say 8,000, just that's the total change, right? So that's your impulse. And then it says if the time of the impulse was 2 seconds, determine the force that acted on the car. So then we're going to use another definition of impulse. Impulse is force times time, right? So we know our impulse was 8,000. So and I'll go ahead and stick with the negative 8,000. Is force times our time is 2 seconds. And so we divide this and we get negative 4,000. This is kilogram meters per second. And if you divide by 2 seconds, you get negative 4,000 kilogram meters per second squared, which are newtons. So negative 4,000 newtons, meaning then the negative here is just signifying the direction, right? So really, if you just wanted like how much force, it'd be 4,000 newtons. But if you want to know what direction that force was applied, you can say the negative, which usually means left or down. Again, so that negative, you wouldn't get marked off for not having it, or wouldn't get marked off for having it. Okay, next is explaining and analyzing scientific information. We're talking about whiplash. I'll try to draw you a little diagram here. Whiplash occurs when you have a car. Usually it's like a car is sitting at rest at like a stoplight, right? So you have like, they're waiting to go, right? And then some other car zooms up behind them and smacks right in the back, right? And the person sitting in this seat gets whiplash, right? And the whiplash is like when it is in your neck, right? And so the reason you get whiplash is when this person hits your car, the whole car. So right now you're at rest, right? And inertia says you want to stay at rest, right? So right now you're at rest. You want to stay at rest. This car hits you. and pretty much everything on your body is attached to the car, right? Like you're sitting on the car, so the seat pushes, like the person pushes the car pushes the seat pushes on your back and your legs and your butt and pushes everything forward. But typically your head is not right up against the seat, right? So typically your head is kind of in free motion, so your head wants to stay where it is, right? So your head wants to stay there. The rest of your body wants to move forward, right? Because of inertia, your head wants to stay there. The rest of your body wants to move forward. So your head like wants to be over here while your body's here, but of course it's connected by your neck. And so your head basically jerks back, and that hurts your neck, right? That stretches out the muscles in your neck. And so no, is it really thrown backward? No. Everything else is thrown forward. Your head wants to stay where it is because of inertia. Right, so that's that. You can also look at some videos, just do a quick YouTube of whiplash, and it'll show you some cool diagrams and stuff. Next one is an experiment is performed to confirm Newton's second law. Newton's second law is force equals mass times acceleration. Mass times acceleration, there it is. So they're graphing acceleration down here and force here. And it says draw a trend line, so the trend line would just be, as close to as many points as possible with about as many above as are below. So there's A, we did that. What is the significance of the trend line? Explain your answer. Well, the trend line gives us like the average of all these points, right? It tells us, because some of our points probably have some error in them, like when we calculated them, there might have been human error or like measurement error or whatever. That's why they're not perfectly aligned. The trend line tells us like the average of all those errors. If we could do it perfectly, maybe it might lie on that trend line. And then also the trend line says that as acceleration increases, so does force, right? As we increase acceleration, force also increases. And then C is asking, determine the mass of the cart. So now we're going to use force equals mass times acceleration. We could use one of the points that's on the trend line. Let's use this one because it looks like it's an actual point that's on the trend line as well. So we're going to use 40, 25, right? 40 is acceleration, 25 is the force. So we have 25 equals 40 times, or mass times 40. So then mass equals 25 over 40, which is 5 over 8, right? Let's see, 5 over 8, 0.625, and that would be kilograms, right, of that, whatever object that is. Which is, if you want to do in grams, 625 grams, and it would depend on which point you used here. If you used a different point, or if your trend line looks slightly different, then you might get a slightly different value, right? If you use like the answer key in the book uses this point, I think. I don't know what the answer key in the book uses, but this is good. Improvements in safety features in modern car design have made cars much safer to drive using knowledge of what you have learned in science to evaluate 3 safety features. You could just look at what seat belts do, what airbags do, and I don't know what else. Oh yeah, the crumple zone. Right, this was actually a question we did on a previous practice set, so you can just go back and look at that if you want, or look at the answer key document. Explain why skydivers bend their legs as they land on the ground after a jump. So you can imagine there's a skydiver coming down. He has a parachute, obviously. The ground's down here. He's coming down. He's coming down pretty fast. When he hits the ground, he typically bends his legs. Right? And the question is, why would you bend your legs? Well, imagine you came down just straight on your legs like this, right? Well, that if your legs are straight, then all that force occurs at one instant, right? Like you hit the ground and all that force goes directly into your legs at a very small amount of time. If you bend your legs, you're absorbing some of that energy by increasing the time in which you're in contact with the ground, right? Increasing the time of the collision. And according to impulse, right? Impulse is force times time. If I increase the time, I decrease the force, right? So if I bend my legs, I'm increasing the time of the impact, which then decreases the force of the impact, which impact in this case is the impulse, right? The answers to 5, there's a really good explanation in the answer key, so you can just read that and reach out if you have more specific questions on that one, right?